Well, we're here. So yesterday we covered primary pollutants, and if you notice, carbon dioxide is on this diagram, and then you look up other ones online and it's not. It's just the way it is. Secondary pollutants are mixing of primary or primary mixing with other compounds to form secondary pollutants. The ones that I underline in red are the ones we're going to kind of focus on during this unit, okay? So here's one really important pollutant that I didn't talk about before, which is ozone. A pollutant, when we know in the stratosphere, it's our sunscreen, right? But when it's in the troposphere, it's actually a toxic chemical that leads to a couple of problems like direct that affect your health, one of them being smog. So they call ozone good ozone in the stratosphere, and when you look at it in the troposphere, they literally reference it as bad ozone. It shouldn't be there, but it does happen, and it causes, like everything, respiratory infections and affects plants. Plants are usually going to be the first target of problems or health-related problems of organisms because their defense is direct. Remember, they're the ones that take in those chemicals from the atmosphere.
So they're like indicators?
So not indicators, but they're prone to have more problems and damage. Yes.
Okay, this is not a secondary?
It is a secondary. Learn more about problems. So again, I introduced primary pollutants, the ones we're going to focus on and the problems that are associated with them. And then I'm going to focus on the problems. But these are some factors that will decrease the potential of those pollutants lingering or forming or causing problems. Okay, because it has to be in large quantities for it to cause problems. Who could help me out with any of these? What are some things that will decrease air pollution? Good. Heavier. They'll fall to the ground instead of being in the air. Now, will it lead to ground pollution? It might, which is our next chapter, but we're now talking about air. And this will help bring down the particle from being concentrated in the atmosphere. What else? Precipitation, definitely. Will wash out, okay? Water is a universal solvent. So anytime water's involved, there's going to be some diluting, right? What else? The pictures should help. Ocean, good. Sea spray, actually. So that constant pouring out of water, again, will help reduce or dissolve the chemicals. Nope. Wind, good. And the last one is always, people have trouble, but any form of chemical reaction will reduce pollutants, right? So if you have a pollutant that's in the atmosphere and it tends to react with other compounds, it might become something that's not a pollutant. Definitely. So factors that increase pollution. Not just urbanization, but what about urbanization? What about it? I need a specific answer. So yes, urbanization, industry leads to the construction of, like, is there more pollution if you live out west or if you live out east? Why?
More cities.
More cities means more what? More buildings. Good, guys. Okay, we got urbanization leads to construction of buildings, or heavy populated obviously is also going to lead. But we're talking about what will concentrate the pollution more, and the buildings will, and so will what? What's this? Mountains and hills. Good. So it's going to be the same concept. So what do hills and mountains do, or urban buildings do? And this is kind of like a word art. You're going to decipher these words. So what do you think urban buildings and hills and mountains do? Yes?
Well, if wind helps to decrease it, it's blocking wind.
So it's going to slow down wind, which is going to what? Decrease? Good. Reactions or dilution or breaking down of the compounds. These examples are actually problems that lead to increases of pollution, okay? So, I mean, it's kind of something new to you. It's not something that increases a chemical. It actually produces the chemical and increases pollution, okay? So for starters, temperatures. Although temperatures can have an effect on diluting, they also can promote, and especially when we're talking about smog. So smog, which is going to be one of the biggest problems, happens during mainly during the day when the temperatures start to rise. Volatile organic compounds are directly linked to specific trees like the oak and the kudzu. There's actually a case study in your textbook about the kudzu, and they both contribute to smog, okay, and particulate matter, and but it's a big problem of an increase of volatile organic compounds. This grasshopper effect, basically what happens is when pollutants are in tropical areas, so although I said high temperatures promote chemical reactions that lead to smog, they also promote reactions that will let the chemicals go up and kind of get out of our troposphere, out of their heavy concentration. But when pollutants are transported from tropical to temperate, or from temperate to polar, or from warm to cold, yes, the pollutants tend to fall to the ground or stay more stagnant in the troposphere where you're more affected. So that's not good, okay? And then temperature inversions. Normal temperature in the stratosphere is warm to cool. So you see warm, cool, cooler. As you go up, right? Troposphere, stratosphere, we're getting to the colder mesosphere. But sometimes the troposphere's temperatures get inverted and you have cool, then warm, then cool. And when the pollutants are supposed to rise and dilute, instead they come back down and become stagnant in the troposphere. So they increase in the area where we're going to be most affected. That's called a temperature inversion. And here's a picture of trapped emissions due to temperature inversions. And basically it forms smog. So when you see the word temperature inversions, you have to know the correct temperature for a troposphere. But you also have to know that it contributes to smog. And that's a picture of actually a temperature inversion and a smog in LA, which I'll give you a little more on that tomorrow.